All right, this video is just going to display how you can use the calculator to get normal percentages. So you'll recognize a couple of these problems from a warm-up I assigned, and I included some others just so you could have some variety. So to start with, we have a scenario. Mr. Adair spends a full day at Charlotte Motor Speedway testing some new tires on his Toyota Sequoia. For 400 laps, he records his time in minutes. And I'm just going to draw this out real quick just so we can understand what's going on. So it's going to follow a normal curve with the mean of 1.84, which is going to be right there, and a standard deviation of 0.07. So we'll count out by 0.07s. And of course, adding that would be, let's see, 1.91, 1.98. 3 out would be 2.05. Let's go backwards, 1.77, 1.7, and 1.63. And you can estimate with the empirical rule. Remember that these two standard deviations out left and right are about 34%. Another 13.5% here, 2.35% there, and then the remaining would be 0.15%. But we're not going to use that. We're going to use a calculator. So just for context, this is kind of backwards. This almost tripped me up. But the higher the time, that's going to be actually a slower. So you just got to think backwards here. And then the smaller the time, that's going to be faster. Okay. So just keep that in mind as we're doing this problem. What proportion of Mr. Adair's laps are less than 1.79 minutes? So what we're going to do is, instead of trying to do a table and a z-score, we're going to do this using technology. So we'll use both the TI-83 and 84 so you can see them both. What you'll do on the TI-84 is you'll hit second vars, normal CDF. Second vars, normal CDF. The lower bound would be, since it's less than, negative infinity. You'll notice that the default is going to be -1E99. That's basically the smallest number your calculator can make, and you can get that by typing -1, and then you can do second, the comma, that's the E. That just means times 10 to the whatever power, and this is 99th power. So there's just a really, really small negative number. So essentially negative infinity. The upper bound would be the 1.79 since it's talking about lower than that. So the mean and standard deviation, notice the mean is in standard deviation default are 0 and 1. That's if it's set to a z-score. But if you want to change those, you can input your numbers in there, 1.84 and 0.07. And so we notice that our percent below 1.79 minutes, which is like somewhere right there, we're getting about 23.75%. So what you can write on this, after you sketch a curve, always sketch a curve, talk about it, but you can write normal CDF, and you can input those numbers. So you can say negative infinity, 1.79, 1.84, and 0.07. And so that's your standard deviation, there's your mean. And that's understood that that's everything below 1.79. And so we get 0.2375. So of course, I'm not talking about writing this up right now. You will have to write in context what that means. You'd say 23.75% of the time, Mr. Adair's laps would be less than 1.79 minutes. But right now, I'm just going to show you how to get the values. Let's say you have an older model calculator. So whether it's a TI-83 or an 84 that doesn't have the newer software, some of them don't. You'll do second vars, normal CDF. Notice that there is no upper and lower and all that stuff. You have to input that stuff manually. So you're still going to start with negative infinity. So you say -1, second comma for the E. That's right there, 99. So there's your negative infinity. Then you'll do 1.79. Then your mean, 1.84, and your standard deviation. So you always put your lower, upper, mean, and standard deviation in that order. Lower, upper, mean, and standard deviation. And it's going to be the same value. The next one, what proportion of Mr. Adair's laps are more than 1.79 minutes? Well, when you're going more than, then that means, you know, visually, we're talking about, if we're at 1.9, that's going to be somewhere over here. I would expect that to be somewhere over 16% because these last three are 16%, so somewhere a little bit over 16%. So anything to the right of that, so it's going to have an upper bound of infinity and a lower bound of 1.91. So you'd write it a little bit different. You do second vars, normal CDF. Your lower bound this time would be 1.9. Your upper bound has to be positive infinity, so you do +1 E99. And we have the same mean and standard deviation, so we'll keep that. And yeah, it's more than 16%. It's almost 20, 19.57, 19.6%. So the probability Mr. Adair's laps are more than 1.9 minutes is about 19.6%. So we can write sometimes you have percents that are between numbers. That's actually a little less work because you don't have to write the infinity sign. You just put what's between them. So for number 3, what proportion of Mr. Adair's laps are between two numbers? You would just do, and I'll use the older calculator, but you would say the lower bound first, 1.75, comma the upper bound, which is 1.85 in this problem. Same mean, 1.84, same standard deviation. So lower and upper bound, and you would find in this problem 45.75% are between those. So that's between 1.75 and 1.85. It's about 45%, which makes sense. That's a big chunk there. So normal CDF, 1.75, comma 1.85, 1.84, 0.07. If I had a little bit more vertical space, I would just write lower equals this upper mean standard deviation, but I'm just kind of paraphrasing it here, what you put in the calculator. So this is 0.4575. So that's how you can get percentages in the calculator. Now, in the next problems, we're dealing with percentages, trying to get values from there. So like in letter D, what lap type is necessary for Mr. Adair to be in the fastest 3% of all his laps? Let's talk about what that means first. So the fastest 3%, that's somewhere over here, right? Like faster is going this way. So it's less than some value, which we can find out. But every operation is an inverse operation. So your calculators also have something called an inverse norm. And the way inverse norm works on both calculators is it does the lower than direction, just like the table does. So back on the same menu, second vars, inverse norm is number 3. The area that it's asking for is going to be a decimal between 0 and 1. So it's going to be the area below a certain point. So if we're looking at, even though on my picture it's the less than 3%, remember faster is that way. So We're looking at the lower 3% of the times, 0.03, not 3. So we wanna do for the area 0.03. And then for the mean, we would change that to the same mean and standard deviation, so 1.84 and 0.07. And so he would have to have a time of 1.708 or less for him to qualify in as fast as 3%. And you can do it on here too. Second bars, inverse norm. You do the 0.03, comma, 1.84, comma, 0.07. So a time faster than 1.708 or 1.71. So what you can write for your inputs in inverse norm, and you just put your area, which is 0.03, your mean, and your standard deviation. And so the time would be 1.71 minutes. It's not a proportion, it's a time, so we have to write a unit. And remember, I'm not dealing with context when I'm writing here, but anytime you're doing a free response problem, you always want to say he would have to have a time of less than 1.71 minutes or less to be in the fastest 3% of all of his laps. So context is always going to be important when you're doing these. All right, last one, it says 90% of Mr. Adair's time laps are faster than what time? I'm going to change that to slower just so we can get an idea of the difference here. Okay, so faster is to the left side. So if it was slower, I can do both, you know, but you hopefully you get the idea. So if it was slower, 90% of the laps are slower than what time? Well, that would be some big number. 90% here, that's most of it. But then the time would be like down over here, if that makes sense. But then when we're talking about the inverse norm, we always want to deal with the area to the left. Sorry, my camera is the opposite, so it's just fooling with me. So to the left of the curve. So you'd want to really think about this problem here. Okay, what's the bottom 10%, and then everything else is slower than that. So you do the inverse norm with 10%. 0.1, 1.84, and 0.07. So let's do that real quick. I'm just going to do it on the 84. You know, you can go back and edit these too. So if you want to type it in this way, instead of 0.03, you can say 0.10. And you would find that time to be 1.75 seconds. So 90% of Mr. Adair's laps are slower than 1.75 seconds. Minutes. If I had kept the original problem, and if it was faster, then we'd have to stick with the 0.9, and so you'll see the difference there. If that were 90%, 90% would be faster than 1.93 seconds, but slower than 90% would be slower than 1.75 seconds. So kind of one end or the other of the curve. So hopefully that's kind of a good visual for helping you understand some of the calculator tricks that we can use. And hopefully, thank you for watching, and hopefully that helps.